Good morning. Next, my college. Andrea, Jimena, Diana, and her servant, Daniela. Next, please. He will introducing you to the subject of equations of the plane in space. Planes in three-dimensional space play a foundational role in various fields, such as analytic geometry, um, physics, and engineering. By understanding the equations that describe these planes, we can address a wide range of problems. From determining the relative positions of objects in the space to design architecture structures and calculating trajectories of moving particles. In addition, the ability to illusion and work with planes in space allows to use to model and solve real world situations with greater precision and efficiency through the use of mathematics to the geometric concepts. We can explore and better understand the complexity of the three-dimensional environment. Its definitions mention that a plane, a three-dimensional object that is definite if we cannot upon the belongs to the plane and the wave vectors that are linearly independent. In the three-dimensional space, a plane can be represented by a general equation from the form ax plus bg plus c d ma equation 0, where A, B, and C are the components of the vector normal to the plane and D is the constant term. This normal vector is perpendicular to the plane and determines its origin in its place. Thank you.
To determine a plane of space, you need to know a point, a pair of vectors that form a base. That is a linearly independent. This is a linearly independent, and this is the for the point to belong. And this is to the plane. The vector has be coplanar with the vector, and that's it. Is independent linearly. This system has to be compatible, determinant in the unknowns, and there before that's determinant on the explained mark of the system with the column and of independent term has to be equal to
Parametric equation. The parametric equation difference of line are not unequal if a different parallel vector or a different point on the line is used. A different and equivalent representation is obtained. Each set of parametric equations leads to relative set a symmetric equation. So it follows is a symmetric equation of line is also not unique. Distance between a point and line, 2 points that L is a line the plan and the M is any point that is not on the line. The when define the distance d of M to as the language of the line segment MP where P is the line il touch that MP is perpendicular to L.
The characters. Equations for a plane. We know that a line is determined by two points. In other words, for any two distinct points, there is exactly one line passing through those points, where in the two dimensions were three. Likewise, give any 3 points that do not outlined on the same. Um, there is a single plane that pass through there's points too. Rela- relations entre lines. Relaciones entre líneas. Give it two lines in the two-dimensional plane. The lines are equal are the parallel but not equal. In the intersecting the single point in their dimensions are four cases in the possible of two lines is special are not parallel but though no interesting then they are said to be sweet lines. Equations for a plane. We know that a line is determined by 2 points, and another words for any two different points, there is exactly one. There that a place through those points, either in two dimensions or the in three, in the same way that any 3 points that are not all the same line. There is a single plan that goes through these points.